Okay, so what did we get for the first one over here? Looking for angle X here.
I got 65, but I don't think it's right.
Okay, well, here's 71. This angle has to be 71. This one and this one all have to be 71 degrees, right? This is 44. This one, and this one all have to be 44. With that, we now have enough information because this is a straight line. These three must add up to a straight line, right? So we've got 180 minus 44 is 136 minus 71 is 65 degrees. Over here, it's a little trickier. This one's 70, this one's 70, and this one's 70. This one's 48, meaning this one's 48. But more importantly, or 148, I should say, but more importantly, that means this one's 32. You know why that one's 32? Makes a straight line. If that one's 32, this one here is 110. Again, straight line. What do we know about this angle? The three angles inside a triangle must add up to 180. So this is 38 degrees there. If that's 38, this is 38, this is 38, and this is 38. Correct? So we said this was 70. This one is 59. That makes this one 59. Also makes this one 59. And this one 59. But it doesn't matter. We already have enough information right now. I'm going to look at this triangle right here. As I sometimes do, I'm going to draw it bigger so I can actually see it. This we said was 38. This one here we said was 59. That makes this one how big? Yes, right, 83. I was going to say 93 for a second there, but it's 83. 83 degrees. That's right here, which makes this one 97. X is 97. Loads of fun, right? I guarantee you on your next unit test, there's going to be a problem like this. With a pair of parallel lines and like 3 or 4 lines cutting across it, making triangles. And so any questions on that? The fact that, okay, if we're looking at this line right here, of course, these are the parallel lines. This angle, this angle, this angle, and this angle all have to be the same, right? That makes this angle have to be supplements, or 180 minus that angle. The total of these two has to be the supplement, and the total of these two. There was actually several ways we could have gone about finding that 97, by the way. Yeah, we had the 70 here. We had 70 and 59 we could have subtracted to get this angle. This would have been 180 minus 38. Then you know that a four-sided figure has 360 degrees. Yeah, there's 4 or 5 different directions you could have gone at it. Yeah, you could have found this angle here and done it, because you know this one and this one. There are a lot of ways to get to that one. So one of the biggest things we want to look at, we've looked at a little bit, things like this. Oh, let's say that this here is 8 inches. We'll call that one 16 inches. Call this X, and this one here we'll call 15. Find X. Remember how we do this?
Yep.
Well, we can match up the 8 with the 6, or 16 with the 12, either one. How do I know which ones to match up? How do I know whether that 16 matches up with the 12 or the 15? Yeah, the angles. The 16 is between the 1 hash and the 2 hash angle. The 12 is between the 1 hash and the 2 hash angle. Right? I could use either one. I could use the 8 and the 6 too if I wanted to.
I'm thinking of why there's 2 lines and 1 not.
Here? That's just to show that it's different, yeah. These are both marked with 2 hashes. That's telling me that those two are the same. Those two angles are equal. These two are marked with 1 hash here and here. That's telling me that those two angles are the same. So now, X goes with the 16 or the 12. Because they're from the same triangle. And then from the other triangle, what corresponds to X? 15. So that goes here. So we will have 16 times 15 divided by 12 is 20. X is 20 inches. We've done those similar triangles before. Does it have to be a triangle? Exactly. You're thinking, why does he have to draw such stupid looking shapes, right? The thought crossed your mind?
Oh, you're a scribbler at heart, you know it.
Okay, so let's say that this is now this one I'm being nice and I am leaving them in the same orientation instead of rotating them. And I will tell you, this angle is equal to this angle, and this angle here is equal to this angle, and this angle is equal to this angle, and this angle is equal to this angle, and this one is equal to this one. All the angles are equal, in other words. We have to know that because in a triangle, we only need to know 2 of the angles. In a polygon like this, where there's more than 3 sides, it's not quite as simple. You have to know all the angles except for 1. So now that we know that, we know these are similar. So how would I go about finding X? 8 and 12. Okay, you could also have done 6 to 9. Would have worked as well. Equals, where's X going to go? Top or bottom? Bottom, because it's from the same figure as the 12. What corresponds to the X from the other figure? 10. Okay. So we'll cross multiply, divide. 12 times 10 divided by 8 is 15. For Y, we're going to continue with the 8 and the 12. Where's the Y go, top or bottom? Y goes on top because it's from the figure with the 8 in it. What goes on bottom? Say 21. We cross multiply and divide. 8 times 21 divided by 12 is going to give us 14. And we'll keep going with the 8 and the 12. Where's Z go? Bottom. So the same figure as the 12. You had a 50-50 shot. Why not take a stab, right? What goes above the Z? 12. Cross multiply and divide. We get 18. And for W, we still got 8 to 12. W goes top or bottom? Bottom. The same figure as the 12. And what goes above it? 26. So we cross multiply. Oops, we cross multiply and divide to get W is 39. Questions? Quiz? Eager Beaver's here today.
Eager Beaver. Plural.
Only one of you is eager. So let's say we have a triangle like this. That is, let's just put in 16, 18, and 12. And I'm going to draw a line here that's parallel to this side here. And this is going to be 5 units long here. There. Do I know the length of this line? Can I find the length of that line? Yes, I can. I can take this triangle inside here and I can pull it out. What do I know about that triangle right now? All the angles are the same. So they're similar. Do I know any of the sides? I know all 3 sides of this triangle. Do I know any of the sides of this one? That's 11. How did I get that? Perfect. 16 minus 5. So this is what I'm looking for. I know the 16 matches up with the 11 as 12 matches up with X. So 11 times 12 is 132 divided by 16, 8.25. Easy enough? By the way, could I have found this distance? It's not going to be minus 5. But the ratio of 16 to 18 is going to be the same as the ratio of 5 to that distance. So 18 times 5 divided by 16, 5.625. So there's all sorts of things that have to be proportional in these when you start dealing with lines parallel to one of the sides. Okay, so we've talked about similar figures. Let's talk about polygons. We've talked a lot about triangles. Triangle is a polygon. It's just 3 sides. What if it has 4 sides? Well, squares and rectangles are types of these. The name is quadrilateral. Could be a square, a rectangle, a parallelogram, a trapezoid, a rhombus. What if it has 5 sides? Try not to get excited over this one, Dustin. Pentagon. So 6 sides is called hexagon. Remember what 7 sides is called? Septa or hepta. There's actually both names are acceptable. Realistically, there's not many practical uses for 7-sided figures, so they don't come up a whole lot. 8-sided? Octagon. 9? Nano. Nonagon. 10? Decagon. And that's really as far as it's really practical to go. I mean, you could have 11, which is an decagon. You know, I guess what 12 is?
12?
Yeah. Dodecagon. Remember, I guess what the 13 is?
Try something.
Actually, I don't even know what 13 is. Most people say tridecagon. I'm not sure what 13 is. You've got the internet.
I know, I'm looking for that right now.
Oh, there you go.
13-sided polygon. Why do you even know that?
That's what the internet says. Why do you want to know, darn you? Okay, so when we're looking at these polygons, there's something called regular. A regular polygon is a polygon, let's say for example, what's that?
Tridecagon.
It is trideca, okay. So let's say we have a regular hexagon. Pretend that looks like a regular hexagon. Well, whenever I draw, you must pretend. One rule about a regular hexagon is all the sides have to be equal. To be a regular polygon, all the sides have to be equal. Also, all the interior angles must be equal. Therefore, on a regular polygon, we can tell what those angles are because we can find the angle sum. How do we find the angle sum? It's 180 times n minus 2. What is n? Number of sides. This is 180 times 6 minus 2, otherwise known as 720 degrees. So the interior angle sum is 720 degrees. How many interior angles are there? 6. If we divide that by 6, we get 120. Each of those angles is 120 degrees. As we get into trig, this will be very important because now that we know those angles, we can start applying our trig functions to them. One of the biggest tricks in trig, by the way, is take the center of a polygon, bring it out, and of course it's going to cut that angle in half. So I got a 60-degree angle there. And triangles and triangles and triangles, yes. Within those polygons, we looked at quadrilaterals. We looked at triangles quite a bit, and we'll look at triangles more. But let's look at quadrilaterals for a while. You mentioned rectangles and all that, but a quadrilateral is just any figure with 4 sides. It makes any closed figure, I should say, with 4 sides. That's a quadrilateral, has 4 sides. Not regular in any way. Well, probably the first step in quadrilaterals is something that looks like this, which is called a trapezoid. Definition of a trapezoid is it just has one pair of opposite sides that are parallel. So there's one pair of parallel sides. Stepping up from the trapezoid, something looks like this, called a parallelogram. I butchered that, didn't I? No, I didn't. Okay. Parallelogram. In a parallelogram, there are 2 pairs of parallel sides. Those are parallel and those are parallel. Next qualification is a rectangle. A rectangle is just a parallelogram that has a right angle in it. Because if one angle is a right angle, since these two sides are parallel, this has to be a right angle. And since these two sides are parallel, this has to be a right angle. And all that one's got to be a right angle too. Now, one thing about parallelograms, opposite sides have to be the same length. Those two sides have to be the same length. Those two sides got to be the same length. So obviously, in a rectangle, it's the same way. We can have a figure that's a parallelogram where all four sides are the same, which is called a rhombus. If you take a rhombus and give it right angles, or if you take a rectangle and give it equal sides, you get a square. So the square is obviously the most restrictive. It has to have the most qualities met, most items met in order to qualify. And then there's also something called a kite. It is an actual shape. Yep. Those two adjacent sides are equal, and these two adjacent sides are equal. So that means this angle, well, those two angles aren't going to be related at all. I should take that out. That means this angle and this angle are going to be the same. These two angles are going to be supplements, usually. I should be careful, not necessarily if it's not a right kite. But there's actually different classifications of kites, too. There's right kites and non-right kites and obtuse kites. And, yeah, it shouldn't have to be that complicated, should it? So anyway, all those different qualifications we'll look at. So within these polygons, let's look at triangles again. We said we were going to back off and look at triangles again. There were some special triangles that we had. A triangle like this was called isosceles. We also stated that the largest side was going to be opposite the largest angle, correct? Smallest side is going to be opposite the smallest angle. So between this angle and this angle, which one has to be larger? They have to be equal. Why? They're opposite equal sides. So in an isosceles triangle, there will always be two angles that are equal because their opposite sides are equal. Because of that, if I take the angle that is between the two equal sides, and there are three structures we can create from the angle of a triangle. One is called an angle bisector. An angle bisector cuts this angle in half. So it cuts it into two equal pieces. Well, guess what? I now have two triangles. This one and this one. And I know that this angle and this angle are the same. I know that this angle and this angle are the same. Well, if two angles are the same, the third one has to be the same, right? This one and this one? Makes sense? So I have two triangles that are now congruent, because obviously this side and this side were the same before. This side in the middle here is equal to itself, right? But more importantly, if this angle is equal to this angle, they also must add up to 180, a straight line. That means they both have to be 90 degrees, or right angles. Which leads us to the second structure. If I draw a line from a vertex to the opposite side, and I hit the opposite side at a right angle, it's called an altitude. I could use the length of that to find the area of this triangle, because it forms a right angle at that side. Remember we said to have two perpendicular dimensions to find areas? So that angle bisector is also the altitude, because it hits the opposite side at a right angle. If I draw in an altitude, do you think it's also going to be an angle bisector? Yeah, in an isosceles triangle it will be. Now we said since it forms two triangles that are equal, this piece then is going to equal that piece, correct? Not a rectangle, makes it a median. If I draw a line from a vertex to the opposite side and it cuts the opposite side into two equal pieces, it's a median. Now in a regular triangle, the angle bisector, the altitude, and the median are going to be very different. For example, let's do, I didn't make that near as skewed as I wanted to. Let me do it this way. So for this triangle, from this top angle, the altitude is going to look like this. There's the altitude. Angle bisector is going to cut that angle in half, here and here. So it looks something like that. The median is going to cut this side in half. It's going to look something like that. So the median, the altitude, and the angle bisector are usually different. But in an isosceles triangle, they are all the same. How about an equilateral triangle? First of all, do we know the angles? Yeah, all three angles must be equal, and since they add up to 180, in the equilateral triangle, no matter what, the angles are all 60, no matter how big the triangle is or whatever. So if I draw an altitude from this vertex over to that side, and altitude, of course, means it hits at a right angle. What do I know about this angle and this angle? They're the same. They're both 30. They cut it in half. What do I know about the length of this and the length of this? They're equal. They're half the length of the side. Okay, so in your packet, I believe 295 is in the packet I gave you. Look, 295. 1 through 24. And I also have a present for you guys to take home over the weekend with you. A quiz. Sure.